Hi everyone, welcome you all to this webinar on data analytics using Python and Spark. I hope you all are able to hear me well. So today, we are going to, this is a little hands-on webinar. So what we'll be doing is looking at some theory, looking at why Spark is relevant in today's world and why Python and Spark make for a killer combination to analyze data and especially to analyze big data. And then we will also dive in and look at some code. We have a live data set which we will query and try to run some Spark scripts on it written in Python and see the results and understand the results. So without further delay, let's dive into the agenda and see what all we are going to cover in the next 1 hour. So if you have any questions, please pour those questions in as you get them in the questions tab. And in the end of last 10 minutes or so, I will try to answer all of them. Great. So let's look at what our agenda is for today. Right. So first we'll start off with, why Spark? Why is Spark relevant? Why are we doing this webinar? Why are more and more companies adopting Spark to analyze big data? After that, we will see why Python and Spark make for a great combination for data analysts and data scientists to work with big data. So that will be all the theory part of this webinar. Post that, we will take a data set that I have found, an open source data set, and we'll try to first understand what the data set is about. And once we get a grasp of what the data is, we will next move on and list and see all the insights that we're going to derive from that data using Spark and Python. And after that comes the real fun part where, I will run you through some code, code for each of the insights that we are going to find, and we'll run it on Spark and actually look at the output. So that's the agenda that we're going to do for today. And, I hope by the end of it, you'll be convinced that Python and Spark form a great combination to do big data analytics. So moving on, the first item I want to cover is why Spark for big data analytics. So there are many reasons why Spark is becoming more and more popular, and some of them is what I have listed here. The first is Spark is, way faster in execution than traditional MapReduce using Hadoop. So Spark was built with, was built way after MapReduce and Hadoop came up, and it learned from all the mistakes and it learned from all the problems that Hadoop was running into. So the way it has been designed is, Spark allows you to, specify all your operations. And then when you say execute, it creates, a step-by-step procedure. It knows what all you want to do with the data. So it optimizes the execution plan so that your MapReduce job or whatever job you're running on your big data can execute faster. So the key takeaway is it is faster than traditional MapReduce using Hadoop. The next reason why Spark shines is it can run anywhere. What do I mean by that? So what I mean is Spark can run on your laptop, which is what I am doing for this webinar. So I'm just using this laptop from which I'm presenting this webinar, and Spark is going to run on it and derive insights from the data that I'm going to point it to. Then Spark can also run on its own on the cloud, creating a cluster. So you can spin up machines on EC2, Amazon EC2, and install Spark on it to create a distributed processing engine, which can then, talk to data present in different systems and, do distributed computing and analytics. So Spark can run standalone on your laptop. It can form a cluster on a set of machines on the cloud. And the beauty is Spark also integrates with Hadoop. So if you already have a huge Hadoop cluster deployed in your organization and you've been doing the traditional MapReduce kind of paradigm, Spark will seamlessly come and sit on top of the cluster and use the same resources to run your Spark queries. So, Spark can talk to Yarn. Yarn is the execution engine of Hadoop. So it can talk to that and use the machines that you have dedicated for your Hadoop cluster and use them to run its jobs. So that's a great win. So you don't need to set up a new set of machines. You don't need to set up it doesn't matter whether you already have a Hadoop cluster or you're just starting out with big data analytics in your organization, Spark can run anywhere. The next big win that Spark provides is its ability to analyze data present anywhere. So the reality of modern computing is data resides in many different types of sources. So for this webinar, the data that I'm analyzing resides on my laptop's hard drive. But in real life, you'll find data existing in SQL databases, like your PostgreSQL, your MySQL, your Oracles, your all these relational databases. So data can exist there. Data can also exist in an existing Hadoop cluster on its HDFS, on its distributed file system. Data can exist in a columnar store like HBase or Cassandra. Your data you could already have a Hadoop cluster where you have created a Hive schema and you have been running Hive queries so far. So the beauty of Spark is all these sources and many more. It can run anywhere and it can access data present on any of these locations. A lot of time connecting to data. What you should be worried about as a data analyst or a big data engineer is about analyzing the big data, processing the big data. And that's what Spark makes easy using these two things. It can run anywhere, it can analyze data present anywhere. Next, moving on, the other big win that Spark provides, it's very simple to work with. It removes all the clutter and the complexity that a huge Hadoop stack brings in. So if you had to do traditionally run a big Hadoop stack, the things that you'd be using is, you'd be using MapReduce, maybe written in Java, then you'd be using Hive separately installed, so that you can do data warehousing. You might have some form of streaming solution. You might have installed Mahout to do machine learning on Hadoop. So what Spark does is it hides away all these complexities and gives you one single interface, which is called the RDB. It stands for the Resilient Distributed Data Set. So essentially what Spark does is, and then creates one interface for you to work with, which is called the RDB. So you don't have to, if you want to do machine learning, you still work with an RDB. If you want to run a SQL query on your data using Spark, you still work with an RDB. If you want to write a traditional MapReduce job, you still work with an RDB. And these are all the examples that we will see further down in this webinar. So this is another big win in my eyes. Learning new technologies, new technology stacks to do something is, to me, a waste of time. What you should have is a solid toolkit which gives you a unified interface with which you can do all these different types of big data analytics. Right. So as I mentioned in the previous point, Spark is much more than MapReduce. So Spark at its core allows you to do anything that you could do with a MapReduce job on Hadoop. But as I said, it also provides other components. So Spark is essentially 5 components together. They are the Spark core, which gives you the ability to do MapReduce kind of operations. And then there is a Spark SQL, which is exactly a replacement for Hive, Apache Hive, which is a Hadoop stack. It's an element in the Hadoop stack to do data warehousing and run SQL queries on your data. So Spark gives you Spark SQL, which is equivalent to that. Spark also gives you, ability to do machine learning via its MLLib, which stands for Machine Learning Library, which is built into Spark. Using that, you can do all the predictive analysis, regression analysis, cluster data, all the machine learning techniques that you would have applied on, you would want to apply on your big data are all packaged into the MLLib part of Spark. Then Spark also has a streaming component with which, let us say, Flipkart opens up a big billion sale. And as the sale is going along, it is reading all the tweets where the big billion sale is hashtagged and trying to figure out the sentiment of how people are feeling about the sale. Are they able to find products that they want? Are they liking the deals they are getting? So such a use case demands you to, stream all the tweets that are being made real time and then process them to derive in this case, the insight which is the customer sentiment. Right? So Spark also has a streaming component with which you can access stream of data which is getting generated and do whatever analytics you want do on it. The other beautiful part of Spark is, the component called GraphX. What GraphX is, it gives you ability to play with graph data, like social networks. So if, let us say, you had access to friends of friends, who are my friends and who are their friends and who are their friends and so on and so forth, and you want to do some form of analysis, you want to recommend people that I want to connect with or I could befriend. So Spark provides GraphX, which allows you to do, graph computing or, graph algorithms on big data. Because if we take all the people that exist on the planet and we, map out who's friends with whom, that I think, will qualify as big data. And then Spark GraphX can be used to analyze that. So in a sense, Spark is much more than MapReduce. It provides you a core with which you can do MapReduce and similar operations, but it also provides you a SQL interface, a machine learning library, a stream processing engine, and a graph processing engine. So those are the reasons that I think Spark is most relevant for big data analytics. Moving on, why is this talk about Spark and Python? What's special about Python? The first reason I could think of while writing this is because Python rocks. Python is just plain simple, the best programming language I have been exposed to. And, I have been exposed in my career so far, I have been exposed to a few programming languages starting from Java to JavaScript to Ruby to Python. And, if doomsday came and I had to pick one language that should survive, I would probably pick Python or JavaScript. But Python, that's a close race. Basically, Python rocks, the code looks simple, it's easy to write, lesser boilerplate, more output. It makes you very productive. So that's why Python is relevant. Moving on, most people, who are already data engineers or scientists know Python. Python is, in fact, a recent survey revealed that Python is the most popular language among data engineers and scientists. So in case you guys, any of you are not yet familiar with Python, I would strongly advocate you to, get your hands dirty and learn Python, because that is going to be the language for data analytics and big data analytics in the future. Another reason why this talk is about Python plus Spark is because Spark supports Python. So Spark has a programming interface in Python, so you can use Python method, or you can write code in Python and submit that code to Spark, and Spark will run it for you. Spark itself is written in a language called Scala, which I personally dislike. It's a pretty complicated language to me. So if you want the most native, feel, you should learn Scala and write your Spark scripts in Scala. But I would like to impress on you in the next half an hour or so how Python code is much more simple and much more easy to write and easy to understand. Also, Spark supports other languages like Java and R. So if you're familiar with R, Spark R can be used to write your Spark scripts in R, and Spark will go ahead and run it for you. So that's the reasons I think Python is, makes a great combination with Spark. Let's move on. Okay, so now we are done with most of the theory that I wanted to go through in this webinar. What I would now want to do is understand the data set we are going to be using in the next half an hour. So the data set that I picked for this data set from an organization called Brooklyn, where they have collected ratings on real movies given by real people. So the data set has two parts. One is the movie catalog, where they have listed down the movies, the names of the movies, the year in which it was released, the genre of the movie, is it an action movie or a comedy movie, so on and so forth. So there is a catalog of all the movies. And then there is another file, a CSV file, which has the ratings given to those movies by users. So let's actually take a break from this presentation and look at the data itself. Right. So this is the movie catalog, which is CSV file. So the first column is the movie ID they have generated for us. The second is the name of the movie. The third is the year it was released, and so on and so forth. So what's important is this has all the movies that real movies that you and me would have seen. The other file that is there in this data set is the ratings data. So this is again a CSV file, and what it has 4 columns. The first column signifies the user ID who is given the rating. The second column, which I have highlighted, signifies the movie ID which he is rating. The third column is the actual rating given by this user to this movie. And the fourth column is the Unix timestamp when he gave that rating. So the first line, if I had to read it out, actually let me take the fourth line, is user 196 rated movie 242, 3-star at this time. So if you wanted to know which is the movie 242, we could go here and look it up. Yeah, it's a movie called Kolya, which was released in 1996. So the user 196 rated the movie Kolya 3 stars at this time. So this is how the data is structured. Now, because this is a talk about big data analytics using Spark, what the data set that I have picked has only 1 lakh movie ratings. There are 1 lakh ratings in this file, but they have bigger data. The group lens have exposed a bigger data set as well, which has I think 20 million movie ratings, real movie ratings given by different users. So that would, for the purposes of this session, I have chosen a subset of it which has 1 lakh ratings, but all the code, everything that we would look at, would run equally well on the 10 million or the 20 million movie data set if you run it on a cluster of machines. Because I'm running the code on my laptop, I have picked this 1 lakh movie rating data set. Great. So I hope we have an understanding of our data. So we have 2 files. One is the movie catalog, which has a movie ID and a movie name. The second is the ratings file, which has which user rated which movie, what rating, and at what time. Right? And we have 1 lakh such ratings. Great. So let's go back. So now that we have an understanding of the data set we can analyze, let us now list down the kind of insights we want to derive from the data. And then we will go ahead with writing some code in Python, which will extract those insights for us. Okay. So what are the insights we're going to derive? The first insight we're going to derive is the ratings histogram. So as you can see, the ratings users have given in this data set range from 1 star to 5 star. 1 star, 2 star, 3 star, 4 star, and 5 star. What we are going to do first is using the Spark core package or the core module of Spark. We are going to extract how many 1-star movies exist, how many 1-star ratings have been given by users, how many 2-star ratings have been given by users, and so on and so forth. Once we do that, we will move on and try to find how are the ratings of the movie Godfather distributed? How many 1-star ratings has it got? How many 2-star rating has it got? And so on and so forth. For that, we'll be using the Spark map reduce. So I'll show you how to do map reduce using Spark. Then we will move on to find which are the most rated movies. Which movies have got most number of ratings, the top 5. For this, I will be using the Spark SQL module, and we will actually write a SQL and ask Spark to run it on our data and return the top 5 movies which have been rated the most. And the last example that I have for today is to build a real movie recommendation system using Spark machine learning library, where given a user, we would, given a user ID, we would find movies that we should recommend to him, given the data we have. All right. So let's move on now. But yeah, before moving on, I wanted to also point out, some resources that I've used, which will be handy for you post this webinar. So first is the documentation of PySpark, because we are going to use PySpark to write Python Spark scripts in Python. This is the documentation link. The next is how do you install Python and Spark, whether on your machine or on the cloud or on EC2 or on your Hadoop cluster. I have pointed you to some documentation which will help you do that. Next is the data set itself that you guys just looked at. That's a link to that. And the last is the code, all the code that I have, I'm going to show you. It is all available at my GitHub repo, and the link is given right here. All right, so in interest of time, let's dive in and let's look at the code. All right, so the first insight we wanted to derive is how are the ratings? How many 1-star ratings are there in this data set? How many 2-star and so on and so forth, which is the ratings histogram. So this is the code for it, and let me try to walk you through it. So in Spark, the main thing or the main interface that I told you about is the RDD. So to create a Spark RDD, you first need a Spark configuration. And the Spark configuration is essentially where you tell where the Spark cluster is located, whether it is located on your local machine, or is it located at some URI, or on a set of machines deployed on EC2. So this is what I'm doing here in this line. I am essentially telling Spark that I'm going to use my local machine, and you can set a name to this app that we are going to, the program that we're going to run, and I've named it as ratings histogram. Once we have this configuration, we can create a Spark context, because now we are, using a Spark cluster to do a job. So we create a Spark configuration by passing it the object that we just created. Once we have the Spark context, we can create the RDD, which is the core of Spark, which is the primary interface with which you will be working. So as I said, RDDs, Spark can connect to data existing anywhere, and that abstraction, comes from RDD. So you can just take the Spark context that you created, and it has various methods. So I'm using the text file method because I am trying to, create an RDD from data existing on my local machine. But this file : / could be as well replaced with an HDFS : / in which case Spark will connect to that HDFS location and try to create an RDD from that data. You can also, connect to relational databases. You can connect to various things. But finally, what you get is a RDD. So what I've done is I've taken this file, which is view.csv, and I have pointed Spark to it and asked it to create a RDD. So an RDD is more like, a distributed data set, which essentially is like an iterative interface. So what you can do is you can, pass functions to it and ask it to manipulate the data and extract the results. So once we have this, lines RDD, where each line in this file is what each element in that RDD is, what we need to do is count how many 5-star ratings are there, how many 1-star, 3-star. So all I'm interested in is the third column. So to do that, what I say is you take the lines RDD that you just created and run a function, which is what the map function does. I'm passing it a function that I want it to run on each of the rows in the RDD. In this case, all I need to do is split that row and extract the second column. The third column, which is accessed by the index 2. So once I do that, essentially the RDD, has all of this. So I've taken one RDD, which is the lines RDD, called the map function on it, passed the actual function that it needs to run on each row, and created another RDD. So this is the most common operation you'll be doing with RDDs. You will transform one RDD into another RDD by using the map function, where you specify the logic. So this RDD has the entire line. Every line is there, the entire line. Whereas once we run the map function and we ask it to split and extract the third column, then all we are left with is an RDD which has just this third column. Once you have that, what RDD also gives you are actions. So you can take an RDD, you can transform it into another RDD using the map function, but RDDs also give you the ability to run actions on them. And one such action is count by value. What that essentially does is, counts how many unique values are there in this and how many times they exist. And it returns that insight or that result to you as a dictionary. So what we have done is taken the lines RDD, created an RDD out of this file. We have transformed that into another RDD which just has the ratings in it. And then we have used an action on the RDD, which is count by value, and counted how many unique values exist in that RDD and how many times they exist, which is exactly what we wanted to do. You wanted to count how many ratings exist and how many times they exist. So once you do that, Spark will go ahead. Once you do this action, so whenever you so I'll take a little detour and try to explain this concept here. So given an RDD that you have created, you can either transform it or you can run actions on it. The way Spark optimizes its execution is till you issue an action like count by value, Spark does nothing. Spark is only tracking all the transformations that you have done so far, right? And then once you have done all your transformations and you invoke an action like count by value, Spark now knows what are all the operations you need to do before extracting that insight, before running that action. So it can group all of them together and run them, send it once to the cluster. So that is one way Spark optimizes its execution. So when you actually run this lines rdd.map, it does nothing. It just remembers, okay, you want to take this lines RDD and you want to, convert it into another RDD. But when you do an action like count by value, that's when Spark goes out to the cluster, issues the command to its nodes and asks it to actually do the computation. So it can optimize because it already knows what are all the transformations you want to do and what is the exact action that you want to, run on the resultant RDD. Great. And once we do this, we get a dictionary, a Python dictionary, which is the result. And all I'm doing here is just, sorting it by key and printing it. So let's go ahead and try to run this. So just to mention, I'm using the Canopy nthought Canopy editor for Python, which is what I would recommend if you guys are just starting out to use an IDE like Canopy. And once you have Canopy set up, that's there in the documentation that I pointed you to, you can, open a terminal. Now, the script that we have written here is the ratings histogram is not here. Okay, this is the script. And to submit it to Spark, all you need to do is spark-submit ratingshistogram.py, this file. And this file itself knows where to connect to, where is the Spark cluster, and what RDD to create, what RDD to transform, what action to run, right? So once you submit this, the job will be submitted to the cluster and the results will be printed out on the client, which in this case is my laptop. Okay, so those are the results. So the 1-star rating has been given 6,000 times nearly. The 2-star rating has been given 11,000 times nearly, and so on and so forth. What we can see from this data is essentially, the 1-star rating is given very infrequently. That's a direct, insight we can draw. People reserve 1 star for something they really hate. And, till the time they reach that, or they really dislike, until the time they reach, to find a movie like that, they don't rate. So once, or people, when they dislike a movie, they just don't come and rate it, maybe, right? So that's this. The 2-star rating is more. So people, give 2-star ratings more than 1 star. And, similarly, people give 4-star is the most common rating given by users. Same way, maybe human psychology, they reserve the 5-star rating for something really special, something that is, getting made. Yeah. So what we did here is, we understood this code and we submitted the job to the Spark cluster using Spark submit, which is a command you will get once you install Spark on your client device, right? So with Spark submit, you can take a Spark script that you wrote, submit it to the cluster, and you can play around with RDDs. Great. Now let's move on to the next example that I wanted to cover, which is the movies ratings. Given a movie, how are its ratings distributed? So for that, the file is called movie ratings distribution.py. And I'm going to skip the first few lines because we have already done that run through that in the last example. I'm going to move to line number 7 directly. So from our data set, we know that if we search for Godfather, the movie ID is 127. So essentially, what I've done is I'm trying to find how are the ratings of Godfather movie distributed. So the movie ID is 127. And I know that in my data, the movie ID column is the second column, and the ratings column is the third column, right? So again, same, I am reading the same file, I'm creating a lines RDD from it. But this time, I want to only look at ratings that are for the movie Godfather. So, what I need to do here is, I, need to filter this RDD and only get those rows where the movie ID column has the value 127. That is what this line of code does. So it takes one RDD, uses the filter function to create a subset RDD. It's again an RDD transformation, which is this. These are all the ratings that the movie has got. And now what I wanted to show you is how to do map reduce. So what we want to do here is, we want to, count how many 1-star ratings Godfather has got, how many 2-star ratings, and so on and so forth. To do that, my map, so I can take an RDD and execute a map function on it, where on each of the ratings Godfather has got, I am, emitting the key as the rating and the value as 1. So if Godfather had got 1,000 1-star ratings, which I hope it hasn't, then, this function will run on those 1,000 rows, and for each row it will emit, a tuple. This is a tuple, where the first element is the rating, which is 1-star in this case, and the second element is a count 1, signifying that, 1-star rating, I have seen 1-star rating once. Then again it sees the 1-star rating, it will again emit 1-star rating, comma 1. So essentially for each 1-star rating I am emitting a 1, for each 2-star rating I am emitting a 1. So all I need to do in my reduce is add those up. Because by the time reduce is called, all the values, that I've emitted for a rating are all put together. That's how map reduce works. So when reduce is called, all my 1-star ratings have all, all ones that I'm emitting here for my 1-star ratings are all together. So to, count how many 1-star ratings I've got, I just need to add them. So we take the RDD we created, we run a map function on it, and we then reduce by key, and we just add up the ones that we are emitting for each key. And then the collect function is again an action which essentially goes and collects all the values in your resultant RDD. So here we took an RDD, we transformed it using the map function, then we ran the reduce by key, transformed it into another RDD, and then we collected all the values. So this is a map reduce example using Spark, and I hope you all can see how simple it is and how clean it is. And then we just, print out the ratings. So let's go ahead and run this. Okay, so what we're going to run is the movie, yeah, this is the script. So again, to submit, we do Spark submit movie ratings distribution.py, which is the file that we have. Once we submit it, it should go ahead and tell us how the ratings of the movie Godfather has varied, how many 1-star, how many 2-star. So just waiting for it to complete. All right, there's a result. So as expected, and Godfather has got mostly 4 or 5-star ratings because it's an amazing movie. And there are a few strange people who have given it 1 star. Great. That's an insight. There are strange people who rate Godfather 1 star and 2 star. All right. So what did we do? We just, took our data set. We created an RDD from it, and then we filtered it to only have ratings from the Godfather movie, which the Godfather movie has got. Then we ran a map reduce job on that RDD to extract how the ratings of the movie Godfather is distributed. Great. Let's move on. All right. So the next thing that I wanted to cover is how to find the movies which have been rated the most. So we want to find among all the movies which have been rated, the 1 lakh ratings that we have, which 5 movies have been rated the most, or which 10 movies have been rated the most? The assumption being those would all be good movies, because we have already seen that people come and rate when they like movies. So the technique that I'm going to introduce here is Spark SQL. So we are going to actually write a SQL query to extract this. So again, you create, so now we are entering into a territory where we are talking with structured data. If you have to run SQL queries, there has to be a schema that you have to associate with your data. If you look at this file, there is no inherent schema in it. It is more like a data frame. It is more like a sparse matrix, right? Not a sparse, it's a dense populated matrix, but it's like a matrix. It doesn't tell you what is A, what does A column stand for, what does B column stand for, what does the third column stand for. So when you have to do Spark SQL, you essentially have to assign schema to your data, and that is what this mapper is doing. What this mapper function is doing is it's taking one line at a time, splitting it by the tab character, so that it gets access to each of these values. And then it is saying I want to return a row, which is a Spark's way of representing a row in an RDD. And essentially for each line that I'm processing in this function, I'm returning a row where I'm saying the first field is the user ID, the second field is the movie ID, the third field is the rating, and the fourth field is the timestamp at which the rating was given. Once I have this, what I can do is, I can take my lines RDD, which is the raw RDD, transform it into a ratings RDD, where the RDD consists of row objects now, because this mapper function is what I'm passing here. So I'm taking each line and I'm passing it this function, which is then converting it into another RDD. But this time, instead of having raw data inside it, it has structured data inside it in the form of rows. Once I have that, I just have to give the table a name, and I'm calling this table as movie ratings because they are ratings of movies. And now once we have this, we can write SQL queries like this. So to find the top rated movies, what I'm doing is I'm selecting the movie ID and I'm counting the rating, that the number of ratings it has got, after grouping it by the movie ID. After that, I'm ordering the result in the descending order so that the movies which are rated most come on top, and I'm picking the top 10. This is the SQL query, and to run it, it's so simple. You just have to say spark.sql. Spark is the Spark session that you have to create now. This is a new abstraction, but it's still boilerplate code, one line of boilerplate code to create the Spark object, and then you can, take your raw RDD, assign it a schema, give a name to that schema, and run a query on that schema. That's how simple it is, and then just print out the results. So here we are doing the collect, which is the action. We are taking this RDD. So when you do spark.sql and you pass the query, it gives you another RDD because the results, you might be selecting all the ratings for all it knows. So you have to run an action on the RDD, which is the collect action here. After that, you can just print the movies. So let's see which are the most rated movies. So again, Spark submit. The file is most rated movies.py. So this is only looking at the 1 lakh ratings, subset of ratings that we have, but I'm hoping some good movies will show up here. That's the job getting delegated. And you see the job progress came after it wrote the most rated movies are. It wrote this line, and after that, when it executed the collect, that's when the job was, you could see the progress bar here, right? So till you do an action on an RDD, nothing really happens, and that's how Spark does all its magic. Okay, so movie ID 50 is the most rated movie. Let's find out which movie that is. Go to a data set. Star Wars. Wow. Okay, let's look at movie number 258, which has the second most number of ratings, which is 509. What is 258? It's the movie called Contact. Great. I want to check out one more. What's the movie ID 100? Fargo. Yeah, that's a nice movie. I like that. Yeah, so essentially, what we have seen here is we have taken a raw RDD, transformed it into RDD containing row objects, which is the abstraction for structured data. After that, we have given a name to that structured data so that we can refer that name in our SQL query. So the name you give here is the name that you can refer as the table name in your SQL query. And then we just executed the query, which gave another RDD. We ran the collect action on it, and that's when the entire thing was delegated. That's when the lines RDD was actually created in the cluster. That's when the mapper ran, and that's when the query ran, and the results were printed. Great, let's move on. We are running a little short on time. So the last example I wanted to run through is essentially creating a movie recommendation system. So how can we create a movie recommendation system with this data? So let us say, this user 0 who rated the movie 55 star is me, right? So what I've done is I have just entered these 3 rows manually, and I have picked some movies that I like, and I've given them 5-star ratings. And basically, I'm fabricated this data. I've put these 3 rows on top of the actual data set, and I have picked movies from this list. Movie 50 is the movie I like, Star Wars, and movie 172 is another movie that I like, and I put this data in so that I can see what movies it recommends to this user who rated these movies with these ratings. So I've taken a few movies I like and given them 5 stars, a few movies I dislike, given it 1 star, and I want to build an engine which can say what movies to recommend to this user based on this data that he has given us. Right. So one way to do that is to look at which movies this user likes and find out which other people like the same movies, and then see which other movies those people like, right? And then recommend those movies to me. So that's a collaborative filtering technique with which we can see how people react, how people have rated different movies, starting with what movies did I rate, and then see the movies that I rated highly, which are the people who also rated those movies highly, and then see which other movies they rated highly, and take a union of all those movies and recommend to me which movies I should see. Right. So that is collaborative filtering, and that's the technique we're going to be using. All right. Again, I'm going to skip all this boilerplate. The main thing to look here is we are now starting to use the machine library component of Spark. And in that, there is a built-in module for recommendation, which we are going to use to create this recommendation engine. Right. So how are we going to do it? So this time, given that we are going to actually recommend movies for the user 0 or whichever user we pass in, what I have done here is read the other file that we have in our data set, this file, so that we can see names of the movies instead of IDs, and then go and see whether that movie is a good recommendation. So I have coded up that part where we will print the names of the movies instead of IDs. So all the data that we need to do the analysis is all present in our ratings data, but the final recommended movies, I wanted to print their names. So what I've done is I have read the other data, the u.item data, which is this file, u.item, and I have created a dictionary where the key is the movie ID and the value is the name of the movie. So all I'm doing here is reading this file line by line, splitting it on the delimiter, picking the first column, which is the movie ID, making it the key, and putting the movie name in the value. That is what this function is supposed to do. It returns the dictionary of movie names. So I'm doing that. After that, what we need to do is now look at our actual data, which is the ratings data, which is this data, right? And what I need to do here is, create a RDD which the MLLib package of Spark can understand and recommend movies to me, right? So the way this works is the MLLib has a ratings object which you can create, where it has 3 columns, where the first column signifies which user gave what rating. Let me check which user gave, which movie got what rating from which user. Yeah. So which movie got what rating and which user rated it. That is the third column. Oops, sorry. So the first column is the user, the second column is the movie, third column is the rating. So it essentially says this user. The first is what you have to pass in is the user. Then you have to tell, which movie he is rating, and then you have to say what rating did he actually give. Yes, that's right. So that's essentially what I'm doing. I have created my raw RDD here, reading the text file. Then I'm transforming it using the map function to split it on the delimiter. So now I'm running another transformation, which is another map function, where now I'm creating an RDD of rating objects. In the last example of SQL, we created an RDD of row objects. Now we are creating an RDD of rating objects. So once you create that, the format in which it expects is, the one we discussed. And once you create that, you can now use machine learning models on it, right? And what I've done here is also called the cache method. So this is a special method. So when you create an RDD, you can call the cache method on it if you intend to use the RDD multiple times. So an RDD is a costly object to create. Let us say you load this file containing 20 million ratings. You don't want to keep loading it again and again and destroy the RDD. You want to load it once and use it and transform it. That's the beauty of functional programming. You create an RDD, it's immutable. You can only transform it into another RDD, or you can extract a metric from it, right? So I have called the cache method, which tells Spark to remember this object because I'll be using it multiple times. And after that, there is a package called ALS, which allows you to train based on the ratings RDD that you created, and ask it to create a model with which we can recommend, right? And after that, to actually recommend the movie that the user actually wants to see, all you need to do is call model.recommend products, pass in which user ID you want to recommend it for, which we are taking in as an argument here, and you're asking how many movies in this case, how many movies you want to recommend, which gives you a collection of recommendations. And then we are just iterating over those recommendations and, printing the name of the movie instead of the ID. So recommendations of 1 will give you the ID of the movie, but we have a dictionary which maps ID to names. So we're going to use that to look up the name and also print how good of a match it is, because it also gives you the score. Okay, so I think I will rush through. So just to summarize, what did we do? So all this part is just creating a dictionary of movie ID to movie name. Great. After that, what we did is we read our ratings data. We into an RDD, the raw RDD. After that, we transformed it to another RDD, which now contains a rating object, which is what Spark gives you. So Spark gives you a rating object, where the format is, which user rated which movie and gave it what rating. That is the format it expects. So the second entity need not be a movie rating. It could be anything, right? If it's an e-commerce setup, this user, ordered this product. Okay. This user, wrote, a review for this product. So this is an abstract rating entity. It could refer to any rating, product rating, it could be movie rating, it could be anything. So what we have done is taken our raw RDD and transformed it to an RDD containing rating objects. And after that, we have used the ALS module to train it with our ratings RDD. And there are a few other parameters which dictate, how many times it should run. These are all internals to this algorithm ALS, which are beyond the scope of this webinar. But that's, with these inputs that you can tweak and play around with, we create the model with which we can recommend. And then we, just read which user we want to recommend, which is an input. I'll show you how to pass input to your Spark scripts. And once we have that, just forget this part of the code for now. Let's go down. Now we can use our model that we created here, right? And ask it to recommend products for this user. This is the name of the method. In our case, it's actually recommending movies, but product is an abstract product. Movie is also a product for, something like Netflix. So the model that you trained here, you are asking it to, recommend products for this user, and you're telling it how many products to recommend. And that gives you a collection of recommendations, which we are iterating and printing so that we can see. And what we are printing is actually the movie name and not the ID of the movie. Okay, so let's go ahead and run this. So Spark submit. It's called movie recommendations.py. This will take a little bit of time to run because the ALS algorithm itself is complex, and it has to, basically for this user, see what movies he liked, take those movies, see which users like those movies, then find out which other movies they like, which are the common movies in that set, then rank them and output them. Okay, so it gave an error because I didn't pass the argument. Okay, so I have to pass a user because here we are reading in which user we want to recommend for as the first argument. So we have to pass that. Let's pass in the user that we fabricated in our data set, the user 0, who like these two movies and dislike this movie, and run it. All right, it's doing all that we discussed about and finding recommendations. All right, so the output that I've got is what are the movies this guy has rated. So he has rated The Shawshank Redemption and Forrest Gump. These are the movies that I like, so I've rated them 5.0, and I've given, I don't know why, but Star Wars a 1-star rating. And these are the movies it has recommended to me. Right, and as we can see, they're not very relevant. None of these movies I've actually seen or even heard from my friends that I should see them because they know what I like. None of them recommended this. So yeah, so that's another takeaway. So don't always, when you use complex algorithms like alternating least square algorithm, the ALS algorithm, don't just look at the output and assume because it's a complex algorithm, the insight would be correct or even meaningful. As we saw in this case, the insight is rather all over the place. So yeah, so I just wanted to impress upon you that the machine learning module of Spark has this capability of building recommendation engines, and at least for the data set and the effort that we put in to train the model, the output do not seem to be very promising. But nonetheless, if we use the right, there are many algorithms in the MLLib toolkit. This is just one. ALS is just one that we have used. There are many like this. So maybe we should use another algorithm. Maybe we should do item-based filtering. Basically look at properties of the movies instead of what other people rated, what other people liked. Instead, maybe we can look at properties of the movies itself. So if I liked Shawshank Redemption and Forrest Gump, what are the other movies done by Morgan Freeman? What are the other movies done by Tom Hanks? Right. So there are different ways, and that is the whole point. You will have to play around. You'll have to always verify the output that you're getting. Never believe that in big data especially, there is easy to get lost and easy to make the wrong conclusions. And yeah, this seems out to be a good example where the insight we are getting is pretty bad. It's always good to go back and look at the recommendations or the predictive analysis the big data system like Spark is giving you, and see if you are using the right algorithm. And that is actually the true data science part of that you'll have to do. Great. So that's all that I had for you guys. I hope the last 1 hour was useful to you guys, and you guys got an idea of how to use Spark and Python to do big data analytics. Thank you.